So, hi everyone, my name is Ramazan Nabidolla. I'm computer science student at Nazarbayev University. I also work at the HRI laboratory as a research assistant, and I'm also a product manager at the startup Kishkentai, a company building AI-powered tools for children with autism. So the topic for me is not just academic, but the topic is what I work usually with every day. Okay, so today I'll present my survey on cross-domain facial emotion recognition for ASD based on 14 recent papers. So let's move on to the main problem. So the main problem is simple. Most AI emotion recognition models are trained on neurotypical faces, and where a smile looks like a clear smile, but children with ACD express emotions in a unique way. One child may show nothing at all, but another may react strongly, but in an unusual way. So the model fails to recognize the emotion, and the gap between training data and reality is called the main shift problem. So let's move on to the analyzing how I solved it. Actually, to analyze this, I picked 14 recent papers on this topic and split them into 4 groups. So the group A is adjusts models internal mathematics. Group B generates synthetic faces with GANs, and Group C abandons pixels and use only landmarks. And Group D is reality check, testing whether these models actually work on clinical data. So let's move to the Group A. Is adversarial feature alignment. The core architecture is done. Done is a feature extractor feeds two branches. One predicts the emotion and the other tries to guess the domain. The main network is trained to fool the discriminator, so the features become domain invariant. And the Valer and Lustrek used the basic done, and John improved it with class aware alignment. Alam used an ensemble, and Wong proposed ACD face for heter sources, and the fatal flaw that these models and methods are accurate on still images but shatter when a child maybe moves its head, which happens all the time with autistic kids. Let's move to the group B. It takes different path. If we don't have enough real photo, we can actually generate them with GAN. So Siholi used style GAN 2, and Su created Harmony Usage, a fully synthetic ethical dataset. Gandhi and Patel focused on early detection, and Godot went very complex, reaching over 95% accuracy. But the fatal flaw is that I call the illusion of reality. Synthetic faces inherit generator biases and often miss the real micro expressions that doctors actually use for diagnosis. This is the drawback of this group. And group C says, forget about pixels, use geometry. This method tracks specific points on the face. Banair and Michaelassi used 2D tracking, which is robust to movement and light enough to run on a table in the clinic itself. That matters because autistic kids don't like being told to sit still. They get stressed easily. Attar and Paygood went 3D using 52 points in 3D space, so the geometry survives head turns. Yes, and the fatal flaw for this method is coarse geometry misses and subtle micro expressions that are critical to ACD. And if the child covers the face with hands, the system goes blind and doesn't even work. So let's move to the group D, and this is the most important group for me. These papers don't build new models, they test the existing ones, and what they find is uncomfortable. G released HRM, a dataset of 130,000 images showing that group A and group B were optimizing for the wrong feature entirely, and SUSE released Count, proving multimodal context, voice plus surroundings is required, not only static photos or videos. Faces alone are not enough, as I said. And Manish Baram ran 3 top AI tools on the same child and got 3 different emotions for the same kid. The critical gap across the whole field is 0 of the 14 methods that I've borrowed have been tested with real doctors. 0. So let's move to this slide. Looking at all 14 papers, I see 2 main conflicts. And the first conflict is pixels versus geometry, and the second is synthetic versus real data. Each side has strengths, but neither of them alone is enough. My recommendation is 3 things. First, merge the thresholds, combine pixel analysis, Gen AI, and 3D tracking into one pipeline. Second is centralized standards so methods can actually be compared. And third, run real clinical testing with real doctors. So in Kazakhstan, like in the rest of the world, there are more and more children with ASD. If we do it right, parents can spend more of their time on themselves. And children will become more calm because we'll finally start to understand them. This is not just about research, this is medicine, this is the real pain and real help for families. So thank you for your attention. Goodbye.